Assalamu alaikum. So the next code in the lab 4 that I am going to explain to you is about is the same is by using the same as BCD LEDs, 7 segment displays, and for that we have to display a clock having 2 digits for hours, 2 digits for minutes, and 2 digits for seconds. To do that, I have used 3 ports of my Arduino, which are DDR-B, DDR-C, and DDR-A, and declared them as an output. And now I have 6 variables. Each one of them is used to represent a specific digit. Starting from the second, as I have used the nested for loops, so we have to start from the most basic of the loops, which is where our all the loops end. So if we see here, the first digit A, goes from 0 to 10, and when it reaches 10, it displays the value at the port A. And I have used a delay of 100 milliseconds and not of 1000 milliseconds. That would make more sense, just to show if the minute and hour clock are actually working or not. So once once the bit A reaches 10, it uh, displays the number at the port A, and then the for loop of A closes, and the for loop of B starts from the beginning. B at the beginning is 0x00, and it has to go to 0x60, and each value of B is to be added into A to give out the sum in the BCD LED 7 segment digits. So same logic is used in the hour and the minute hand. Sorry, in the minute hand, and for the hour, I have set the limit of the my clock at 20 at at 12-hour clock. So when the 12-hour clock is actually working, uh, you have to use a variable that in my case is x, and that x is basically what limits my BCD 7 segment display to 24, and not any number that is a multiple of 10. This code working is shown in this Proteus simulation, and you can see the seconds are now going from 0 to 9, and after that there is an increment in the second hand, and once 60 seconds are complete, the same increment can be seen in the minute hand, in the minute 7 segment displays of our clock. And this was the code for displaying a clock on the 7 segment display. Assalamu alaikum. So this is my code in which I had to display, I had to basically take input from a keypad and display it on any LED or a 7 segment display. So I have opted for a 7 segment display, and I'll explain to you the working of my code in just a minute. First, I'll show you how my circuit is actually connected. These 4 pins are used to give input to the keypad, and these 4 pins are used to take input from the keypad. And there is another port that is the port B, which is connected to this 7 segment display, which is of common cathode type. And in the code, what I've done is I have sequentially given high to each and every row of the keypad, and using the conditional statements if else, we I have told my controller that if any of the column is high, what it had to do. So let's suppose if this row and this row and this column is high, it has to display a 1 on the port B. And to display 1 on the port B, I have shown you in my previous lab that how we have decoded the values that will display a 1 uh, on the 7 segment display, and for displaying the 1 we have to turn on two of these LEDs. And using the same logics, I have implemented my code, and I'll show you it's working just about now. And if I press 0, the 7 segment display shows 0, and the logic behind it is that it turns these 6 LEDs on. If I press 2, it displays 2, 7, 9, 1, 3. Any of the number that you want to display can be displayed. The next task that we have to perform is just using the keypad and the 7 segment display to make a calculator that simply performs addition and subtraction. So first of all, what I've done is I've created an array of my decoded values that will be used to display a specific number on the 7 segment display. I have declared the DDR-A as an output, DDR-B as an output, and DDR-C as an input that it will be connected to the input lines or the columns of the keypad. So how is this code working? The logic that was used in showing of a 7 segment display, it is the same logic that is going to be used here. So once a button is pressed, it starts taking values and storing it into a variable x. No matter what button is pressed, it first stores the value into x. Now after storing any value into x, once an operator is called, the value of a variable check is dependent on what operator is called. So if suppose addition operator is called, the value of check becomes 0xff, and if the subtraction operator is called, the value of check becomes 0x00. And once the operator is called, the code then goes into this label right here, which starts taking values and storing them into another variable that is y. So once the variable y has a value, I just have to press the equal button, and on the basis of what the value of this variable check is, it will show me the results. So suppose if I press addition at the start, the value of check becomes 0xff, and when I press the equal to button, the check is 0xff, and the output becomes x plus y. And similar case is with the negative with the subtraction operator. And the subtraction operator sets the value of check as 0x00, and once the value of check is monitored and it is verified that the value of check is 0x00, the port B displays the value of the character result, which has x minus y. The working of the code is right here. There are little bit of problems that I have not fully optimized my code according to this keypad. My code is optimized for the keypad that we have used in our labs, and let's start working. Let's suppose we press 1 plus 4, which gives us 5. This is the reset button, and 8 minus, let's suppose, 3 is equal to 5 again. 7 minus 4 is equal to 3. 1 plus 1 is equal to 2. So this is the working of my code, and this code right here, and this task right here concludes our lab 4.